Welcome to Chapter 6 Lab Identification of Metamorphic Rocks. To do this lab, well, first you'll watch the video, which will appear here. It's not here because I'm recording it right now. And open this link. The best way to open it is Command-click. First, this link. Love this little target. Command-click, and that will open the link in a new tab. Let's go to it in just a minute. You are going to paste this table, complete with cool colors, into your answer document and fill in the sample texture, foliation, composition, parent rock, and rock name. Choose only from the list and only the things with the little asterisk, the star by them. And yes, you'll notice schist does appear twice. Okay, let's move over to this. Metamorphic rocks, as you know, are rocks that have undergone a change through heat and pressure, but without melting. You're going to fill in the texture. Texture can be divided into two groups, foliated and non-foliated. Okay, foliated. Whoa, take a look. The crystals of the minerals in each of these are stacked up like the leaves in a book, or like leaves from a tree that are stacked up, which kind of makes sense because look at foliate. Foliated, foliage, like leaves. Think of pages in a book. There are also non-foliated metamorphic rocks in which the crystals are just jumbled. They aren't in any particular order. I like to call these massive instead of non-foliated because, I don't know. But your lab calls them non-foliated. The lab says you can have 4 types of foliation: slaty, philitic, schistose, and gneissic. Let's look at those. Slaty means it looks like slate, like the old blackboards. Not very distinct leaves at all. It's just kind of a combination between foliated and massive. Philitic means that the minerals are starting to become shiny. If you've ever hiked near 7th Street and Thunderbird, a lot of the rocks there that you fall on and you get cut up by are phyllite, and the crystals are beginning to separate into visible layers. Schistose means you definitely see the mica coming out, and gneissic means you have real bands, which are very nice. R. Oh, that's bad. Non-foliated. There are 2 non-foliated types of rocks in here that I can recall. Ooh, maybe 3. We have marble, which is made of calcite, and being as it's made of calcite, it will react to hydrochloric acid. And quartz is identifiable because it's really hard. Sorry, quartzite is made of quartz, and it's really hard because it's going to be 7 on Mohs scale. Metaconglomerate, I don't know, do you want to call it non-foliated? It's a conglomerate rock that's been squished. Okay, there's also anthracite coal, which is just bituminous coal that has been squished in the absence of oxygen, so it can't burn. Okay, here's what it's going to look like. Again, as with all the other labs, you can get a close-up image. Let's go through them first. This one definitely has some kind of banding going on. Number 2, whoa, this is cool. I like this. And if you look up close, there are little teeny crystals in there too, in addition to these leaves stacked up. If you were in the lab, you'd be using what is called a loupe, an L-O-U-P-E, loupe, but we call it a loupe. The same thing the jeweler uses to look at diamonds. Let's go to number 3. No real banding at all in there. Number 4. 5. Cool. What a mess. 6, 7, and 8. Now, as an example, we're going to do number 2, and the good news is you get to use these for your answers, so you get credit just for watching this. It's probably not worth it, but watch anyway. Okay, hydrochloric acid test. Let's try the acid on this rock. It doesn't react. I'm not surprised, which means it can't be anything that's made of calcite. So that leaves out marble. This definitely isn't marble, but take a look. Marble has to be non-foliated, and this definitely is foliated. You can see leaves in here. Let's try hardness. Oh, we can't use it on this sample. Oh well. So is this thing foliated or non-foliated? Do you see leaves in here? Or is it just massy, the same thing throughout? I'm going foliated. Would you say it's like a piece of slate, the blackboard of old days? Or is it phylitic, like phyllite? Or is it schistose, where you start to see the crystals coming out? Or do you have real bands? It's not like slate. It's not all black. It's definitely shinier than just phyllite, I think. Hard to tell. And there might be, no, when you look at it close, there are no real bands like gneiss has in it. But you can definitely see that the minerals are all aligned in this direction. Now, as we talked about in the lecture notes, that means the pressure that formed this rock came from the top and from the bottom, which means the minerals lined up perpendicular to that, parallel with each other. So I'm going to go schistose. What does it look like it's made of? This clear stuff is definitely quartz. It looks like feldspar in there to me, so it's got to be something with quartz. Could be either this one or this one, but since we chose schistose, let's go with this one. The parent rock then had to be slate, so whatever this was before is what it is now. That did not make sense at all, but I'm not re-editing this. So that means this rock is schist. Let's see if we are correct. We got them all correct. You're going to copy the texture, the foliation, the composition, the parent rock, and the rock name. Oh, sorry. And put that into your answer key here. It's that easy. You're on your own. Have a good time.